So I'm super sick right now. So if I like start coughing or something in the middle of the talk, like don't be alarmed. Just have to deal with that. So let's talk about Heartbleed, which is one of like my favorite. Stop fucking talking. Which is like one of my favorite security vulnerabilities that's been disclosed recently. Really ever. It's pretty hilarious. We'll get into it. Yeah. So also I'm Jared Shumway. So for some background, there's this thing called SSL, which is the secure sockets layer, and it's used to encrypt traffic over sockets, which is what is like driving network communication in your most of your guys' computers. You guys most likely interact with it through HTTPS, which is just HTTP over the secure socket layer. And importantly, it protects the content of messages, but you know, like the person running the network can't see the content of the messages, but can still see who you're sending messages to. So that's kind of important information to have visible. One of the really popular implementations of it is called OpenSSL, which is an open source project. And it's implemented in things like Apache and Nginx, or it's linked to in Apache and Nginx. And there are companies out there that use this in production. Google doesn't, they have their own implementation, but like projects like GitHub and some like other big sites definitely do. So inside OpenSSL, there's this extension called Heartbeat, which allows a client that is connected to send a message that just has like some content in it, like hello, and then the server will send that message back. And this is, you know, just allows clients to be like, is this server I'm talking to still alive? And that's why it's called Heartbeat. So normally, you know, the example here, you just send a message bird or whatever, and you say it's linked for, and then the server repeats that to you. So with Heartbleed, you can do this. And the echo packet has a 2-byte field, so it's a short. So you can like say the message length is, you know, short max, which is 65,536. And so what this will do is the server will get this message and create a 64K buffer in memory, copy your message into the first 4 bytes of it, or first single byte of it if you want to be really efficient, and just read back to you this huge chunk of memory. Importantly, this memory isn't zeroed because it takes time to zero memory. So like this is just garbage. It's just whatever used to be in RAM at that location. And then cleverly at the bottom here I have, but on an SSL server, garbage from the point of the view of the server might be really useful stuff for the person performing this like little exploit. So what you can do is issue a bunch of these requests and slowly just piece together an image of what the like memory space of this program looks like. And you know, you can imagine the sort of fun things you could find in old memory on an SSL server, like all the session data that has been decrypted and passed to some backend server and then re-encrypted and passed forward back to the client. So like usernames and passwords. You know, what's the first place you interact with SSL? When you're signing in to a website. So username, passwords, session IDs, all that kind of fun stuff. Things that are actually on the server, like certificates, keys being used to encrypt and decrypt all the data. And one problem you might be thinking is like, okay, well, if you have a randomly generated key and you have this garbage looking data, can you really figure out that there's a key in that random data? And the answer is yes. Digital forensics has done a lot of work on how to detect keys in what looks like random memory dumps, because this is a useful thing for them to do, to like, you know, bust some guy's house, take their computer, freeze their RAM, and then go through the RAM and figure out where the useful data is. Exact same stuff works when you're trying to steal shit from an SSL server. So the reason I love this vulnerability is because it's just some small little, like the patch, by the way, for Heartbleed is like a 2-line diff. It's like literally changing a couple little places in a C program. So it's this tiny problem in an extension to the actual project that allows you to dump the entire server's memory over the course of over the course of many requests, and then just take whatever you want from it. And when this was disclosed, the whole security community kind of like collectively shit their pants. Because it's like all of our stuff, like, okay, SSL is probably a secure protocol, but if you have this kind of trash implementation, everybody is screwed. And so it turns out, what was revealed by this is that the OpenSSL codebase is actually just garbage. It's really, really bad. And the OpenBSD project, which is totally separate, a lot of these projects use the word open because they're open source, The OpenBSD project has this like, they just immediately forked the project and started just like cutting out hundreds of like thousands and thousands of lines of just terrible code and rewriting all this stuff so that it'll be secure. One of my favorite like facts about this is that the OpenSSL project created their own library that replaced like, you know, the standard library routines like Malloc and Calloc and all those, which is these really terrible functions. But that prevented tools like Valgrind and some other nice dynamic analysis tools from working. So the first things the OpenBSD developers did was replace this with the standard libraries and then run it through Valgrind and just memory errors everywhere. So it's like, eventually Heartbleed was disclosed, but there were tons of other memory vulnerabilities laying around in this program that we don't know about because they weren't disclosed, but somebody probably did know about them if you're cynical, or hopefully nobody knew about them if you're optimistic. But let's be honest. Yeah, and like nobody audited this code base that they were using that's just like this awful code. Like you guys don't understand how bad this code was. Like this guy wouldn't have gotten through 357 with this kind of code. And nobody audited it when they put it into production for important websites. Like there are big organizations that use GitHub, yeah, to secure their code. And it's like, if somebody had this, you'd be like, oh cool, look, this big corporation's actual code, and you just leak all this important information. But nobody audited the code base. So that's another great implication, but it's just super simple. Nobody looked, and it just means that like, you know, it's not super sexy like Stuxnet was. Like that was like this beautifully engineered virus that exploited like a bunch of 0 days, but this is just super simple. And this is like the thing that's gonna screw us going forward, and why you have to, you know, write good code and stop fucking writing C, because C's terrible. So yeah, let's talk about OpenSSL, or Heartbleed. I'm sure you guys have questions about it, yeah.
So I remember like the notice coming out for it and everything. Who actually who took charge and was like, hey guys, like by the way, you should change your passwords and shit because.
Well, there were a couple different teams. There were two teams that kind of discovered this in parallel and then disclosed it responsibly. And there was just kind of, I don't know if there was any like a big authority who's like, okay, have you guys upgraded your, you know, OpenSSL implementations? It was more like this the security community as a whole said, okay, everybody needs to upgrade with this patch. There were also some cool sites that like went around and tested whether or not people were vulnerable, and then they had this like public shame list of people who weren't. Because yeah, nobody could really go around and like force people to update, but as a community effort. Yeah, Nick? Oh, good.
How are you able to determine, so when you send these packets and get back buffer data, how do you determine what two buffers are next to each other?
Well, so the way that allocation happens is you just say, you know, like, Malloc, give me some memory, and that could be pretty much anywhere, so not really aligned. So what you would hope for is just that they'd overlap, and you could kind of like correlate the pieces and put them together. Also, you can never really get back like a full image, because obviously things that are already in use aren't going to be reallocated, but there's a lot of like very temporary transitive allocations that are happening. But you know, you don't have to have a whole lot of memory to see like a username and password string, which is the other great thing. You can just get a bunch of dumps and then run strings on it and be like, oh look, let's add this to my password cracking database, and then like hit this site. Will be another good attack where you don't have to have a big image. You had a question, and then you?
Yeah, I was gonna say, we were just talking about LastPass.
Oh yeah.
LastPass had a feature where you could like scan through your sites to see which sites were still vulnerable.
Oh yeah.
I remember like 6 or 9 months later, I looked through and there were still like several websites that hadn't updated to the new version of
right.
Or hadn't patched it. Why did it take sites so long?
Well, I mean, there's just a lot of risk inherent in upgrading in production. So like those people have no excuse. Like they should do that. Like a vulnerability that's this easy and exploitable. The other great thing about this is like, it's really hard to detect this happening. People usually don't log simple echo requests. So like your server could be getting hit with this and you'd have no idea. That's the other fun thing. So like those guys have no excuse not to upgrade it. The like pressure on them not to might just be that, you know, bringing down your authentication servers to upgrade them and then bringing them back up has some amount of overhead and difficulty. And OpenSSL is kind of like fragile software. It has pretty poorly designed APIs. So like upgrading it might have some implications on like other code they have to change, but they should do that because it's pretty irresponsible not to. Yeah. Also, I love LastPass.
As kind of the software development community, what's the best way to avoid stuff like this in the future?
So you just have to write better code. I mean, there are certain things to do that are irresponsible, and like replacing your allocation routines in the way that they did is one of them. And you really should be using the standard tools out there, like Valgrind and the Clang Static Analyzer, or like if you have funding or are an open source project, which they are, then Coverity is free. You can have like free Coverity scans. So that's one way. Responsibly writing C is another. And then, yeah, doing code reviews where like, you should like, especially a project that's of this scale, you should have, the OpenSSL project is pretty underfunded, and it's just like a couple guys. But in like a more serious project, which this should have been, is another thing, you would have code reviews. So like everybody's looking at something twice, which is still hard because in C, like I'm sure you guys who are in 3v7 or like in further classes, like it's really easy to, do your math a little bit wrong and end up with memory errors, and like you get seg faults hopefully, or you just get silent memory corruption. So there are other options like writing in programming languages that give you more protection from that. So like there's this awesome programming language called Rust that actually like makes it at compile time that you're guaranteed not to have memory errors, which would like totally solve this problem. Other good things to do are just like write better C code. Also, one other thing, the OpenBSD developers have like this awesome implementation of the Malloc library that will intentionally like do everything it can to make your memory errors like crash your program immediately. And that's like allocating things with guard pages to the left and right so that if you're off by one, it'll crash. Or like when you free something, it'll like corrupt the memory intentionally. So if you have a use after free, it's much more likely to fail. A lot of this library, a lot of stuff they did was setting themselves up to, if they had memory errors, their program would keep running, which sounds good in theory, but is actually the worst thing because that's how bugs, you're never gonna find them. So there's other techniques you can do if you're stuck with writing C that can help you tease out bugs.
And then just one other quick question.
Yeah.
I heard that, or I think I read somewhere that libTLS was also running into some underfunding issues. Did
Oh,
you
yeah.
end up finishing it, or?
I think so. If like the OpenBSD project that they're doing now, I think their funding round for 2014 just finished and 2015 started. I haven't looked at the numbers, but they're getting a lot more funding after this publicity, so I expect that to improve in the future.
Yeah, somebody donated a fuckload of money to them, and they like totally busted all of their like funding goals. Same
Yeah.
with FreeBSD.
Yeah, so it's nice that projects that are doing responsible, like handling these projects responsibly, are getting more funding. Did you have a question, Maggie?
No.
Okay. Anyone else? Yeah.
So, I'm only starting coding, so I don't
Yeah.
know. But why is it that, as well as giving Heartbleed giving the data, it also gave the length? That seems just like I understand it's bad code.
Yeah.
But that's like it seems like there's some sort of error there fundamentally to do with
Right.
not.
It kind of has to do, like there's some networking reasons that happens, and like somebody who knows more should correct me if I'm wrong, but like when you're getting a packet off of a TCP connection, you don't really know where the packet boundaries are. So as you're pulling data off the pipe, you have to like look at the header they're giving you, and somewhere it has to say, okay, how much more data should I expect to receive? Their problem is that they were just trusting that number instead of validating it, was really where their misstep was. Yeah.
This is really just a general networking question.
Yeah.
Are most of the abstract concepts in networking literally kind of like modeled after physicalities like pipes, like we give these names to it, and like in a lot of terms, I mean, you can picture in a physical sense, like, can you literally just like think of like a pipe, information or something flowing out of that?
Right.
You're grabbing it and seeing,
Yeah, I mean, yes and no.
Still, like some of the fundamentals of that?
There is a lot of, like, the reason that analogy is so prevalent is because there is a lot of truth to it, but there are some difficulties, obviously, as well. It really depends on what layer you're talking about as well, because, like, the pipe metaphor is pretty bad at, like, the very low level, because if you're communicating over a bus, it's not like a pipe, because there's no sequential things. It's like you're either, pumping electrons across the bus or you're not, kind of thing. I don't know. It's pretty useful. Yeah. All right, anyone else? Questions about Heartbleed? Awesome bug. Don't write bad C code. Also, this shit is probably in like a bunch of other programs. Like, these are really, really easy errors to make if you're just like, oh, I'm gonna whip up some C code. Like, really easy. So yeah, write good C code, guys. And thanks.
Yeah.